Hello my dear friends, I welcome you all to my channel. This is part 5 on the series of videos on the common path name manipulations functions defined in the module os.path. So if you have not watched the previous 4 parts where I have discussed some other functions from this module os.path, for example os.path.expand user, expand vats, and then split extension, common prefix, common path, and few more. I highly suggest that you also watch the previous 4 parts, previous 4 videos on some other functions defined in the module os.path. So all functions defined in this module os.path are related to common path name manipulations. In this video, I will discuss about 2 other functions defined in this path, which are os.path.exists and os.path. The functions are named, the name of the functions are exists and l-exists. L-exists is the L stands for link. L-exists is same as exists, but it differs for path if it is a symbolic link. So this video is part of the playlist Python Beginners Daily Dose, where I try to come up with some useful information on the basics of Python programming, and I also try to give some insight of how the standard Python libraries work. If you are new to my channel or not yet subscribed, and if you are visiting my channel for the first time or seeing this video for the first time, then I highly request and suggest that you watch the other videos in this playlist, which might be useful to you. If my videos are beneficial to you, then I will strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have prepared my very quick and concise and short notes about the 2 functions that I will discuss in this video, which are exists and l-exists. These are defined in the module os.path, which all the functions defined in these modules are related to common path name manipulations. Okay, the function exists, as you might have already understood from the name. It checks whether a given path, the argument path to this function is, it can be a file path or it can be a open file descriptor. If it is a file path, it will be a string or its byte equivalent, and if it's a file descriptor, it will be an integer representing the file descriptor. That is an open file descriptor. Okay. Now what it does, it checks whether the given path refers to an existing path or not, and depending on some other conditions, it will return true and false. Let's understand when it will return true. It will return true if the path refers to an existing path in the system, and the user, whoever is running the Python script, has the permission to stack the given path or stack the file referred by the argument path. That is, the user, whoever is running the script, must have permission to run execute stat. There is a Unix method stat which gets metadata information for a file or directory. If the user running the script has that permission to run stat, then only it will return true, and provided the path refers to an existing path. Now when it will return false, the exist function will return false, first of all, if the path provided does not exist. It is not referring to an existing path, or the path will also return, this function will also return false if the path is referring to a link. It is referring to a symbolic link which is broken, meaning the symbolic the link that exists, but the actual file to which the link is pointing is referring to, that does not exist. And Okay, so let's try to see how it works. So I have my Python shell interpreter. Let's try to import. I have already guessed import os.path as p. Okay, now let's run the exist method on a existing path. So my home directory is /users. I am on Unix system /users /costub, and let's see what it gives. It says it gives true. So this is my home directory, and definitely it exists and it is giving true. Okay. Now, okay. Now let's see if I have a link. Let me create a soft link. Let me create a temporary, for the purpose of this video, let me create a directory, a temporary random directory, let's say tmp, and now let me create a soft link to this directory. So the command is ln-s that creates a soft link to a file or directory. So I'm creating a soft link to the directory that I just created. So the command is ln-s dot /temp, that is the directory that I want to link to, and the link name, let's say my temp. So my underscore temp is actually the name of the link, and it is basically pointing to the actual directory, that is temp. So if I do ls minus lp and minus my underscore temp, you can see the arrow mark. This says that it is a symbolic link to the actual folder, that is ./temp. Okay, fine. Now I have a link. Now let's see if I run the exist command on. It is under my home directory, my underscore temp. It is giving true. It is giving true. Fine. Now, as I said, the exists function will not work for broken links, broken symbolic links. That is, if the path is a link and the link is broken, that is, the link exists but the actual file or directory to which it is pointing to, it does not exist, then this function exists will return false. So let's try to see how that works. So I have the directory temp tmp, and I have created the link soft link symbolic link my underscore tmp, that is linking to the temp folder in my home directory. Now I will remove the actual directory temp. Now even though if I do ls minus lp my underscore temp, it will still show that it is pointing to, actually it is a link to ./temp, or it is a link to the temp folder that I created, even though the temp folder does not exist. Now if I call this exist function on my underscore temp, it will return false because the link is now broken. So it is now returning false. It is broken. Okay. So that was about a normal path that exists and a path which is a link. So we tested for path that is a valid path, the existing path, and we tested when a path is a link and it is not broken, that is, a link is actually pointing to an existing directory or path, and we tested if it is a link, if the argument to the exist function path is a link, symbolic link, but it is broken. So we saw for broken link it is returning false. Okay. Now let me further discussing on the exists function. Let me quickly discuss what is l-exists. The L stands for link. Now it works more or less same as the exists function. The only difference in functionality will be when the path is a symbolic link. So for l-exists, it will not return false if the path is a symbolic link and is broken. It will not care. Actually, it will. So what is it will return true. So if I run l-exists on the my underscore temp link, which is broken as of now, it will return true because the link itself exists. It is not following the symbolic link. Whereas the exists function, if the path given to exists function path is a link, it will follow the link. It will follow the link until and unless the actual file or path is reached, and then it will see whether that actual path or directory or file is accessible is having enough permission by the user, whoever is running the script. If it has the permission, then it will return true. Otherwise, some system may return false if the actual path is not accessible by the user, whoever is running the Python code or script. Whereas in the l_exists function, if it is a file, or irrespective of whether it is a file or a link, symbolic link, if the user does not have the permission to access the file, then also in l_exists it will return false. So let me try to access, give a path which is not accessible by the current user, which is /users/costov. Now I have an open terminal. I can see. Let me see if I do ls. What is, if I can find some file or directory which I do not have access to. So how can I do that? Now /var. What do I have? /opt. I can let's see, library. Okay, what is there inside the root directory? Is bin. I have. Is there any? It is accessible, but I can see that /var/root. It is not. It is permission denied. It is permission denied. So I cannot access /var/root the directory. Now, oh, okay. So I can see that in the, you cannot see the what I was doing. Oh. So you cannot see the actually the commands I am running on the terminal. You can. So there is a problem when I am switching in this terminal where I am switching. I have two tabs open. When I am in one tab, I have my normal the shell open, and on the other tab I have my Python interpreter running. But I can see in the recording it is only the Python interpreter is showing up. So let me see if I can separate out the tabs. Now let me see if it is visible. No, it is still not visible. Okay, so there is a technical problem. What can I do? So I have to perhaps sorry, please give me a few minutes. I have to add the terminal window captured. Terminal is already exists. Terminal 2. What will this be? Okay. Okay. Now let me see if you can see. Okay, possibly you can see now. Okay, so I have so I have my terminal. Now let me, if it's everything visible. Okay, so in the terminal, if I do /var/root, I can see I have having a permission denied, which means that I cannot access the directory /var/root. But if I now execute these two functions, that is exists and l_exists, on a path where it is not accessible by me from a terminal, if I am doing ls, I am trying ls, running ls command on /var/root, it is giving me permission denied. So from here also p.exists, from the function os.path.exists, this should also give some kind of error, or it should at least return false. It is returning true. I have no idea why it is returning true when in the terminal when I am trying to access /var/root, it is giving permission denied. What about l_exists? I think it will also return true. Okay, it is returning true. Okay, so I'm trying to find an example where I will pass a path which is not accessible, to which the user, whoever is running this function or script, do not have permission. So SU, no, sorry, I don't even know. Okay, what are the, sorry, okay, so what files are there under slash that I cannot access? Is there anything? No. Anyway, so I'm sorry, I can't find any file or directory that I do not have access to. I'm really not that much expert in Unix systems, so sorry, I could not demonstrate that if you pass to exists or l_exists, if you pass a path which is to which the user, whoever is running the script, do not have permission to access that file, then these two functions will return false. So anyway, so now what else? This is an information that the exists function, for to check, it internally calls os.stat. It internally calls os.stat, the function stat, which is basically works as per the stat system call in Unix. So os.stat will be called internally by the exists function. So if os.stat gives any error due to, it gives any kind of permission error that it cannot access the given path or to extract its metadata information, like stat basically returns the information like last access time, last modification time, and last creation time. All this metadata it returns. So if any, for any system that is Windows, Linux or Unix, in whichever system this function is being called from the Python script, in that system, if os.stat gives any error or fails on the path, then this method exists path will return false. Both exists and l_exist will return false. But the only difference with the l_exists and exist is that the l_exist function will not follow the symbolic link. That is, if the path argument to l_exists is a symbolic link, then it will not follow the link. So even if that link could be a broken link, then also it will not follow the link. So it will just try to it will call internally, the l_exist function will internally call the method lstat from the module os. So the lstat method from module os, that is os.lstat, if you give a path, it does not, if the path is a symbolic link, it will not follow the symbolic link. It will not follow the symbolic link. It will only process that link only, whether it exists or not, or whether it has the user permission or not. It will not follow the symbolic link. Whereas exist function, if the path argument is a link, is a symbolic link, it will follow that symbolic link until the absolute file or path directory is reached. Then it will process that actual file or directory. If that file or directory is not user accessible, that is, the user whoever is running the script do not have the required permission, then it will return false. Whereas in l_exists, let's say if you are running if you are executing l_exists function, let's say the path argument is a symbolic link, and the user has the permission on the link to access the link, but the actual file or the directory or any file to which the link is pointing to, that is not user accessible, then also L_exists will return true, because it will not follow the symbolic link. It will not follow the symbolic link. This is the basic difference between the two functions, L_exists and exists. So I hope I was able to explain how these two functions works and what are their functionality regarding when passed path. Okay, so one more thing, if the path to for both of these functions, the path could also be a integer. That means if you pass an integer, it will assume that a file is already opened with that integer. Now let me see if I can demonstrate that. I'm not sure whether I will be able to do it, because I'm not really that much familiar with a file descriptor in Python. So let's say okay, let me clear the, okay, so let's say I open a file. Let's say I open a file. So let me quickly check what files are there in my current directory. What files? Any file? There is no files. Okay. My temp. Okay. So my temp is basically symbolic link that I created, but it is a broken symbolic link because it is pointing to ./temp, and this ./temp folder I have already deleted. So anyway, I don't think it will matter. So let's say I open the link using the, I'm still in the Python interpreter, using the open function. Let's say I ./my temp. So I am opening the link in the read mode. No such file or directory. Why no such file or directory? My underscore temp. Really? File not found error. So if I open a symbolic link and if it is broken, then possibly this open function will fail. Okay, no problem. Let's say I create a file for just using the touch command. I create a file, let's say a temp file, whatever name I'm giving. Let's say temp file.txt. Okay, so now if I open this file that I just created, temp underscore file.txt. So I open the file. So now if is pointing, the open will return the file descriptor. I guess I hope this f is a file descriptor, which is an int. What does f is? Oh no, it's something else. Something else. In the, so exists and L_exists, the path, it is I mean all the functions defined in the module os.path. The path can be three things. It can be a string, normal string of a path, referring to a path, or it could be a byte equivalent of the string, or it could be an integer, that is a open file descriptor. Now I don't think this open function, Python open function, returns a file descriptor or not. Let me see. Now if I try to call let's say exists by passing f, what it returns? No, not text IO wrapper. Okay, so type error, stat, path should be string, bytes, os.path like or integer. Okay, so how can I get so I will quickly do a Google search to see how do we get in Python, how do we get the file descriptor using, let's say, open. I'm sorry for taking some time. I'm just trying to figure out if after using open path, what does it return? Return some, these are returns of a descriptor for newly open file, os.open, path flags mode. Okay, so os.open method. Okay, so there is a method called os.open. I simply called open. The open method that we very normally casually use to open a file for either to read or write. So there is another method open from the OS module. Why is it not? Okay, so let's say I have file descriptor equals to, let me first import the OS module. So import OS, and then I am invoking os.open, and let's say I give the my what was the name, temp file.txt. So this should return, as per the documentation, as I quickly did a Google search, this should return a file descriptor, that is FD should be, no, missing required argument. Oh, flags. Oh, I see, there are some arguments, flags. What is flags? Is bounded with flags to be set for newly set argument. God. So this is a more low level function, os.path. The list of flags, read only, write only. Okay, so os dot read write. Okay, so I have to pass os dot read. What was the name? O underscore read write. O underscore read write. So O underscore read write. Will it work now? Okay. So I had to give the permissions that with which this file will be opened. Now what is FD? So FD now is returning an integer, which clearly shows that the 4 is the file descriptor of the open file. The file has already been opened. Now if I call the exists function with FD, it should return true, and also this L_exists should return true. No, path. Why? Type error, lstat, path should be string, bytes or os path like not int. Oh, I see. Now, so what is happening when I am calling exists? As I explained, as per the notes, the function exists. The function exists will internally call os.stat, and with the argument, same argument as path, which is being passed to the exists function. So internally it will just call os.stat with the same path argument that is being used to invoke the exist function. Now os.stat as path, the path argument to os.stat can be a string, can be a byte, or a file descriptor, whereas in case of L_exists function, it internally calls the method os.lstat, and I guess as per the error it is throwing, that os.lstat will not take a file descriptor as an argument. It will only take a string or bytes or some os.path like object. It will not take int. So that is the reason L_exists is throwing type error when I am invoking it with FD. So this was a little side information, that if you are using os.lstat, that is if you are starting some symbolic link, then it will not work if you give it a file descriptor. It has to be a string or a byte. So yeah, that is all for this video. I hope I was able to give some useful information on the function exists and the L_exists, which is about the checking the existence of a file or a file descriptor or a file descriptor. So as it seems that the L_exists function then will not accept the path argument as integer. So let me quickly, if I can, okay. So anyway, since the L_exists function is internally calling os.lstat, and os.lstat will not accept an integer, that is a file descriptor, as an argument, so it clearly shows that L_exists function you cannot also pass a path descriptor. So it has to be a string referring to a file path, or it has to be a byte equivalent of the string. So that is all. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So there are many other functions left in the module os.path. I will do my best within my limited capacity and understanding to explain the other functions in my upcoming videos. So please stay tuned for those videos, and until the next video, take care and bye.